This is a video that I've wanted to make for at least the last 10 years, and I'm finally getting a chance to do it. Today, we are doing knife lock strength testing. That's right, we are going to test all of these knives. We've got 4 different types of knife locks here. We're going to test them all to failure and find out which knife lock is the strongest and safest type. We have our unlucky contestants right here. We have the Benchmade Bugout. We have the Kizer Varatas, which is an example of a well-designed liner lock. Bugout obviously is a crossbar lock. We have the Lothar Rafael, which is an all-aluminum button lock. We have another crossbar lock. This is a Ganzo G746. And we also have this knife. This is a Buck 110 Auto clone. So this is our Lockback stand-in. We're going to test them all. You can see what I've done is I've drilled holes in these knives. What that's doing is it's allowing me to place the force that tries to break the lock at the same distance from the pivot pin in all of the knives. I'm going to be setting this up in a testing rig that holds onto the blade, and we'll be applying force this way with a crane scale and ratchet mechanism to force the locks to bend, and we'll see how much force it takes to break all these locks. Here we go. Here is my testing rig. I have a rock climbing omnidirectional carabiner, so this will take about 4,000 pounds. I have 1,000-pound static line for rock climbing. My knives are going to be held in this pipe, and it's got a slot so that the knife will only bend this way. There is my crane scale. It is set up to a cable. The cable runs back to this area with those 2 ratchet straps. The ratchet straps will allow me to apply force just a click at a time on that crane scale and let me slowly and incrementally increase the force so that we can tell what happens and when the knives break. Here we go. Oh yeah, and just so you know, there's going to be a big barrier in the middle here, so I will be behind the barrier with a remote, away from all the breaking knife parts. On this testing rig, the knives slot into this slot right here, and the base of the blade braces against this piece of metal right here, so that as the force is applied in a thatward direction, you're getting leverage just on the locking mechanism of the knife. So that's how it's set up. The space from the pivot to the plate there is also going to be standardized for leverage reasons. First up, we have the Kizer Varatas. This is the liner lock. We're going to start adding tension. Getting some movement there. Oh, I heard a crunch. I'm going to check it. All right, I have bottomed out my testing rig, so I'm going to pause this, unlock the tension, and go see what I've got. So what we've got is the liner lock has pushed itself fully over to this side, and it's bent. It hasn't completely failed yet, though, so I'm going to adjust the testing rig, and we'll try again. Okay, so there I heard it go. I know we got to failure that time. I'm going to let the tension off. Here we go, pulling it out of the testing rig. So it looks like, I'll get it in the better light upstairs, but it looks like that whole liner lock metal piece bent so far that it actually blew the scale off the side and cracked off the pivot bolt. So that is actually an incredibly well-designed liner lock. The knife didn't even ever fully close like it would have closed on your hand. So that is, without a doubt, the best designed liner lock I have ever seen. Really, really good job, Kizer. Next up, we have the Bugout. Here we go, adding tension. All right, heard that one go. Let's see what we've got. Well, let's pull it out of the rig. So I don't think anything actually broke on this. I think what happened is there was just so much force that it caused things to flex enough that the blade just slipped under the lock bar this way, and it might have dented some of the metal in there. There is some wiggle to this, but it still locks up. It still functions, although that one did fully close. So if you were holding that, you would have had hand damage, as opposed to the Kizer where you really wouldn't have. So I'll check the poundage. I didn't see from the video how many pounds that was, but it didn't actually break. You can see the lock bar slides a lot further up this way now, but it did fail. On to the next one. Next, we have the button lock. Adding tension to the button lock. That one felt like it went a lot earlier. Let's go check it out. Taking this one out, I don't see anything obviously broken. If I'm looking down at the lock mechanism, I can see where there was some internal slipping in there. It's not super obvious, but there is some lines on that. You can see right there. There's kind of a chunk in the blade. That lock, it definitely sits further up out of the back of the knife than it did before. You can see that lock plunger is almost fully sticking clear up out of here, meaning there was some deformation to the mechanism. This still probably locks up just as firmly as it did before. Obviously, that was not as firmly as some of the other knives, and that lock is almost fully worn out now, but it does still lock up, and there isn't any more blade play than there was when we started. So there's failure on that one. Here's the Ganzo going into the rig. So we've tested sort of a name brand crossbar lock. This is more of a no-name crossbar lock. And I've seen some lock failure videos on these before. So that I'm leaning to believe that this might not be our best performer. But we're going to find out. As Bill Nye always used to say, one test is worth 1,000 expert opinions. Adding tension to the Ganzo. Okay. Very good. Got a failure. Let's see what broke on this one. Again, I don't see. Ooh. Okay, so this will no longer open. Okay. So what actually broke on this one was the steel that stops the lock bar from getting pushed back out of the knife. So you can see on this side, on both sides, it broke off both sides. There should be a steel piece right there that keeps the axis bar from moving backwards. It has snapped off on both sides, meaning the heat treatment on the liner metal of this is probably too hard. If we look at the Bugout, see those pieces of steel right here? That's what keeps the axis bar, those pieces of steel are what keeps the axis bar from getting shoved back that way. They stayed intact on this one, and they snapped completely off on this one. So definite lock failure, and I can't open that anymore. Last but not least, our Lockback is going into the testing rig, adding tension to the Lockback. All right, there's our failure. Taking this one out of the rig. Let's see. It looks like the end of that lock bar sheared off a little bit. Let's see. Okay. So the actual lock bar, now that I push it up, the lock bar bent. So that lock bar should be flat in there. It's bent all the way up. So it actually bent out of the way. And as you can see, that lock is 100% no longer functional. Yeah, that's supposed to be straight. Super interesting failure on that one. And it did bend, but it didn't break. So probably pretty well engineered. Let's look at the final results and talk about how these knives failed and check them out in detail here. So first, we have the Kizer. On the first round, it looked like it held 104 pounds initially, but that was because the rig bottomed out. So the real weight that this held was 93 pounds before failure, and this was it blew off the end of the pivot bolt, cracked the liners open, and bent the heck out of the liner. So that is not usable anymore, but that is a pretty cool catastrophic failure at 93 pounds. Next, we had the Bugout, which did 81.5 pounds of pressure, and it had a lock bar slip failure. So the lock bar slipped back this way and it went down that way. This would probably be a little stronger even if you reprofiled the tang of the knife to be a little flatter, and that might change the ranking of this knife. Next, we had the Lothar button lock, which only did 38 pounds of force, and it had a lock, slip, and wear failure. So you can see this button sticks out way further than it used to because the lock surface kind of smushed a little bit. You can see down in there where the lock goes, it's kind of deformed a little bit. Right there on the bottom on the right-hand side of your screen there. That's a little bit of deformation. So now the bar slides out way far. The button sticks out really far. Kind of a wear out failure there. Still locks up okay, but that's definitely the bottom level there. Next, we had the Ganzo axis crossbar lock, which took 104 pounds and it actually had a liner snap failure. So both beams of steel that used to run over the top here that keep the lock from shooting backwards broke. So that is a total lock failure, but It held a lot of force. Let's move it all the way over here to the left. And finally, last but not least, we had our lockback, which suffered a lock bar bending out this way failure. That's the same direction the lock bar moves when you unlock it this way. So it just forced its way that way as the blade got forced down this way. And it took 99 pounds to break. So this is our final order. This is not what I would have guessed if I had guessed initially. I probably would have guessed this would be the worst, this would be next, and then I probably would have guessed lockback and then the 2-axis locks. But in reality, we had button lock, axis lock, expensive axis lock, inexpensive liner lock, lockback, and then really inexpensive axis lock as our worst to best lock failure testing. One note about my numbers. So you'll notice my failure numbers are a lot lower as far as there are fewer pounds taken required to break the knives than some other tests, notably the one Blade HQ did a while back. That is because I used a much larger distance between the pivot and where I leveraged the locking mechanisms. So that meant that there's a magnification of the force, and the locks are going to break with less force. Blade HQ did theirs like an inch from the pivot bolt, which means they were going to have to take about 3 times as much force to break the locks as I did. I didn't want to apply that much force to cables in my basement, so I used a higher leverage ratio to get the locks to break with less force. I don't think I've ever been so grateful that I own premium safety glasses in my entire life. That video was a ton of fun to shoot. I hope you guys had a ton of fun watching it. I hope you learned something cool too about knife locks and knife strength. If you like this video, please like it. Please subscribe to the channel if you aren't. I have started my Knife Care Masterclass membership. I'm putting up a Waterstone how-to video, how to take care of them, how to use them, and what knives you need them for. We're going to do other knife sharpeners and knife maintenance equipment coming up in the coming months. Check that out. Check out product descriptions and stuff down in the description of the video, and enjoy all this fun, cool, crazy stuff that I got to do today. Also, William wanted to say goodbye to everybody. Say goodbye, William.